So thank you very much. I'm going to stay downstairs because I have to point at slides at some point. So you all see me here. You see the slides. The slides are more important anyway. Okay. Okay, great. First of all, thanks a lot to both Zentyal and CENATIC, because in fact I'm invited by CENATIC. I'm also in the board of advisors for CENATIC, and they were glad enough to tell me we have a slot in the Zentyal Summit and go there if you want, and that's what I did. So in fact this is not a presentation of the company of Bitergia, which is a startup of my research group at the university, but it tries to be a general presentation about how metrics can help you a lot when you are in the free software businesses. The idea here is that there's a lot of things interesting when you talk about free software, which are not usual in other realms of software. First of all, you have the source code available. Everybody knows that. But you can look at the code actually. You can learn from the code. You can learn about the quality of the product, for instance, and you have all the code there to look at it. You don't have to rely on the vendor telling you, okay, this is great. You can look at the product actually and say, okay, this is great or this is not great. You can even contract someone, third party, neutral third party, to do an evaluation of the product based on the source code. Not only a black box analysis that of course can also be possible, but you can actually look at the code. But you also have usually, not always, but usually, an open development model. That means you can not only look at the product, you can look at the process. You can understand what's happening in the company producing the software, or you can understand how the community around the software works. You can understand the processes they have. You can look at the quality analysis they are doing or not. You can see how they are closing tickets or not. You can look at anything you may want. Because if the development model is open, everything is in the open, including, in many cases, major decisions, future functionality, bugs, anything. And you can look at it. You can analyze it. You can get a very first-hand impression of what's happening in the project. And, of course, in free software projects, communities are important, not only companies. Even when companies form communities, you have something which is difficult to define, but in many cases has a lot to do with the success of the product or with the success of the project. For instance, communities are important for sustainability. Is Zentyal going to be out there 10 years from now? Probably, because there is a community interested in having it. And since the community is interested, maybe even the company is not going to be here in 10 years from now. But if the community is going to be, you may be sure that you are going to have some kind of help, of support, anything. That's the reason why we can be confident that, for instance, the Linux kernel is going to survive many, many, many years. And there is no single company behind it. But there is a strong community. You can go there, you can look at the community, you can understand it, you can see how big, how large it is. Of course, for pooling resources, it's the same. If there is enough parties interested, you can get a lot of the resources just by asking them. And of course, innovation, which is quite important, comes in many cases from outside the companies leading the project. It's quite important to understand whether the community is attracting contributions from external parties in terms of innovation, which in many cases is one of the better ways for innovating a product. Okay, let's go forward. So in short, you have information about the code, information about the community, information about development. All that information is out there. It's in the software development forges for the products. You can go there, look at it. The problem is it's complex. You have to retrieve it. You have to analyze it. You have to look at it with care because there's a lot of complexities involved. So the idea is the information is out there, but very people is actually using it. When you do an evaluation of a product, usually what you do is a casual browsing of the community or mailing list, for instance. You try to get an idea of what's happening by having a quick look at the code. Or you may try to understand the development process by reading some documentation and going to the, tracking system, for instance, and try to understand what's happening. But that's quite difficult, especially for large projects, because you have a lot of information, a lot. For instance, big project may have like 20 to 50,000 commits a year. That's a huge amount of changes to the code. So analyzing them just by looking at them is fairly impossible. Even the people deeply involved in the project don't know what's happening in many areas where they are not directly involved. So in the end, what you need is factual data. The great news is the factual data is out there. The problem is you have to go and look for it and extract the information from the noise. Because there is a lot of information, but there is also a lot of noise. You have to be able of keeping up with that. The nice thing is that even very, very simple analysis may be interesting for stakeholders, for people interested in the project. So for instance, I've seen how developers are quite interested when you come to them and tell them basic parameters like how long are you taking to fix bugs. So this is a very, very simple parameter, but it's not that simple to get. To begin with, tracking systems usually involve many things in addition to bugs. So just getting the metric of how long does it take to close a ticket usually is not enough. You have to do more things. But even those metrics and the evolution of those metrics, which are very simple to calculate in the end, are quite important for the projects. And you would be surprised at how many, even let's say professional projects with a lot of companies involved, don't know how long is it taking to fix the bugs. Even last year, medium for the whole year, for instance, they don't know. For users, for integrators, things like, how is the community? Is the community robust? Are they getting external contributions? Which companies are involved? Actually involved in development, not saying I support this product, but producing changes, having developers involved. That's quite important because that's going to be related to the support that product is going to have in the future, the sustainability of the project itself. And for instance, for investors, is the project attracting external resources? Or are they getting fresh blood every month, every year of external developers, external companies came in to contribute? Are they getting people fixing bugs outside the core project? How big is the core development group, in fact? So it's 10 people, it's like 50 people. Are they renovating enough so that I may be reasonably sure that the product is going to survive healthy in the next year? So just as an example, when I knew I was coming here, I tried to make a very quick analysis of Zentyal. So this is the base data. The whole analysis is on a website. You have basically a URL for the blog post if you want to look at it. It's very, very basic. So for two reasons. First, I didn't have a lot of time. Second, I want Zentyal to pay for a more deep analysis at some point. So this is only the basic part. But you can go to the real thing and browse through the graph. So it's basically, we've analyzed it, both the Git repository and the mailing list repositories. So this is basically the basic analysis of the Git repository. And it's telling an interesting story. In the top part, the big graph, the big chart, is commits per month since October 2005 up to September last month. So you can see the trend, you can see where main releases are, and you can see the usual peaks up and down of people, committing a lot of changes just before the release, committing some changes after the release because you find bugs, having those valleys between releases and so on. But you can notice the general trend of more and more changes, which basically means the project is getting more and more activity with respect to changes to the code, which is healthy. If you see a project which is going downward in that direction, that probably means the project entering into maintenance phase. There is no more innovation there. If the project is, let's say, moving, you usually have a trend of more and more commits in the mean over the time. The next chart is the number of committers. So the number of people actually committing something, making a change during that month. Of course, again, you have ups and downs, but you can see it's pretty stable. Is that for the last month, in the last month, don't know exactly, but maybe 6 to 8 months ago, it started a growing rate. So it's difficult to know what's going to happen in the future, but at least it seems there is let's say, a stable community of people committing, people making changes, people maintaining and updating the software. Branches is interesting for technical reasons. I'm not going to enter a lot into it, but basically it's to some extent related to how people is experimenting with the software, how people is trying new features, things like that. That's interesting, but here we have a problem which is like 1 year ago, they moved from Subversion to Git, and that causes a lot of problems with respect to branches. So I wouldn't rely a lot on that data. And file storage, which is the next graph, basically has to do with how extensive changes are. When you have a peak there, that usually means something changed all over the project. So that's usually something like re-architecting the software, but sometimes it's more easy, like a change in license, which involves all the files too. And well, that's all for this. Very briefly, this is the mailing lists, two of the mailing lists. The top one is developers, bottom one is users. In any of them, the top part of the chart is number of messages sent. The bottom part is senders. And you have the top part is senders, middle part is senders, send messages, senders, and on the bottom bar is navigation panel only. So looking at the top part, you can see how the developers mailing list, there was a lot of activity. By the way, sorry, the temporal axis is different. This is from October 2010 to last month, because that's where we had mailing list available. So this is much shorter than the other charts we saw before. Anyway, you have a lot of traffic during a certain part of the year up to, I don't know why, around spring this year, traffic becomes quite slow, just a few of messages every month. And I don't know what that means. I didn't have time to talk to the Zentyal guys. Could mean they are moving discussions elsewhere. Could mean they are not having discussions in the developers mailing list. Both things are quite different and should need some kind of look at the list to see what's happening. The other one is about users. So it's a users mailing list where people, make questions, answer, etc. Pretty much stable traffic, but some rise during the last month. Same with respect to people posting, which could mean maybe in the last months we are either having more visibility for this list or we are actually having more involved users, because people coming here, they are usually not casual users that usually browse the net and that's all. They subscribe to the list and send at least one message. So that's pretty much a good metric for trying to understand what's going to happen with users in the next months. Okay, let's go on. What's this? This is the same. What's this? This is another analysis. So this is all for Zentyal. I'm now going to move to some other analysis we have done in the past to show different angles of what you can learn when looking at this kind of information. So this is OpenStack. OpenStack released it like last week, I guess, the Folsom release, which was like 6 months of work since spring up to now. And these are two views of the companies contributing there. The left part is companies contributing to what the project considers the core part of the project, which is 7 sub-projects. And the right is the whole OpenStack distribution. This is interesting because there is right now a lot of controversy of which companies are actually contributing to OpenStack. And probably the forming of the OpenStack Foundation, there is a lot of discussion on whether the rules are good from the point of view of the internal policy of the project and so on, because basically you have some companies in the board, there is a lot of discussion whether they are actually contributing to the code or not, etc. So basically this is the factual information. So basically you go to the commits made by developers, you identify them by company, and basically you sum the developers for a given company. So there is a little difference between both, that's why both are important, but you can see, for instance, that Red Hat right now is probably the major contributor, or maybe the second one, but in any case, Rackspace and Red Hat are contributing like 70% of what is in OpenStack right now. And then you have some other companies, small companies like Nebula or Sina, but also big companies like HP or IBM. So the important thing about this is this is traceable information, so you can go look at the methodology and see whether you like how these stats have been formed, or you can do it some other way, depending on the criterion you may have for how people are contributing. Okay. Another one. This is about a small project, which is Key Develop, which is a part of KDE. In this case, we did an analysis for them, which is basically how long are you taking to fix tickets, not bugs in this case, but tickets. And this is the graph over the years. So you have starting in 2000 up to 2012, and the different lines are the different quantiles. The blue one is the 25% of the tickets that are closed the faster. So that means that, for instance, in 2012, if you look, it's like 2 and something. The scale on the left is logarithmic, so it's basically 10 to 2 or 10 to 3, so between 100 and 1,000 minutes. So that means that 25% of the bags, of the tickets, were closed in less than, say, probably 500 minutes, which is a pretty good time. The red line is 50%. So even for 50%, they have very good times, and they have been improved a lot during the 10 years of the study. But you can look at the 95% and 99%, and they are remaining high, so it's in the order of 10,000 minutes or 100,000 minutes, which is a lot of time. So that basically means they are very quickly solving like half of the bugs, but they are very slow solving the rest of the bugs. Over time, they have improved a lot in those bugs that they fix fast, but they didn't really improve how they fix the, let's say, more difficult or more slow to fix bugs. So this, you can get some more information from this graph, but this is the very basic idea. So trying to tell you how you are performing from different points of view when you are trying to close tickets. This is still a work in progress because we are going to present at the LibreOffice conference an analysis of LibreOffice. And in fact, this is you go to the Git repository of LibreOffice. Fortunately, they maintain history from the times this was with Zen and later Oracle. So you can get a lot of information for since 2000 up to 2012. And basically, this is a 3D thing, so it's better when you can rotate it and so on. But basically, you can look in this age, we have time. And for every slice of time, we have the distribution of contributors. That basically means first we put the contributor with more commits, then coming up to us, the contributors with less and less and less commits. So basically that means if you have like in the middle, for instance, a lot of high towers, but very little towers coming to me, that means very small group of contributors doing a lot of work. On the other hand, if you look at the right part, for instance, you can see lower high towers, but a lot of towers coming to me, smaller and smaller. That means a lot of people contributing, some of them contributing a lot, some of them contributing much less. So that's what you see on the right part is the usual pattern for communities. So you know there's a core group basically contributing a lot. There are some people contributing seldom. What you see in the middle is the usual pattern for company having a team maintaining the product and nobody else basically touches the product. So they basically work 8 hours a day on the product and they commit a lot, they make a lot of changes, but the team is small. So basically, we still have to refine this because there were some changes also in the policy. So not during all the time, people were actually committing. In some parts of the project, people were submitting changes and only some people could commit. That would explain that part in the middle. But the last part is pretty much reliable. That's the time when the new foundation took over with LibreOffice. And basically, you can see that they are performing right now community style with a large base of developers, which is right now, I don't remember, but it's like 100 developers or something with very, very different styles of contributing. But as I said, this is just work in progress. I'm still not sure of how accurate it is. So in summary, and I'm already finishing. First of all, there's a lot of information out there. So that's something unique to free software, something which makes free software especially interesting, both for developers, but also for users, and for any kind of stakeholders, because they can have access to that information, no NDA, nothing. You just go there, download the data, analyze the data. So the analysis is quite interesting, but getting the data out of the repository and analyzing it correctly may be a bit complex. So maybe that's the reason why there is no that much use for this data up to now. However, we are right now interested in going a step further. So the kind of things I showed you were, let's say, past research in the sense that they are quite simple. We're quite interested in going deeper and looking at things like who is the developer who is more important for the project. We call that the bus factor. If a bus comes and kills one developer, which one is the developer who we are going to be into more trouble if the bus factor works? So that's quite important because you can realize that in some projects they rely on like 3 or 4 developers. They are doing things like 90% of the commits. So if for some reasons, imagine for instance a company hires those developers, the project goes nowhere because the project is basically them, just to mention one example. So we're interested in that kind of deeper analysis, answering specific questions. We're also interested in working with developers. So there's a lot of things here which needs the involvement of developers because they actually know about the policies of the project, etc. And if you want to know something about your pet project, let us know. So we are looking cases to analyze. This is the usual marketing pill or about the company. And look at the website if you want more information. And I hope you learned something. And I don't know if you have some time for questions. Okay, so any question, comment, whichever. Yeah?
What kind of tools you employ? What kind of tools? Yeah. What kind of tools you use? Are own tools? Are open source tools? When you get all this data, part of the value of the company, I guess, is having developed these tools that allow to identify, to analyze the projects. Your company is quite young, so in terms of where do you get these tools, how do you use them, and this kind of stuff?
Okay, good question. We came from the free software community. We have been involved with free software for many years. And we believe that the only way of doing this is with free software itself. For many reasons, but first of all is accountability. I want my tools to be inspected by any other one so that can rely on the tools and can say, okay, this graph was produced with accurate information and with accurate tools. So to begin with, all the tools we are using are free software. In fact, we have a community of developers around them. It's still academic, but we are starting to see how people from some companies start to join to do different things. The tools basically do 2 kind of things. One is retrieving the information from the repositories, from the Git repository, from the tracker repository, whichever, and then analyzing it. The only part that right now we are deciding what to do with it is the visualization part. Right now it's free software. Maybe at some point we're going to have a mixture. Not because we don't want to release everything, but because some of the things we want to use are not free. And so we are still deciding. We would like to be free even for that, because we also understand that this could be useful for free software projects with no company backing them or something. They could be interested in getting the metrics, etc. And basically, if it is a proprietary software, they are not going to use it. And it would be a pity because they are not ever going to be our clients because, they don't have money to pay us. So we are losing nothing if they just do the analysis themselves or whichever. And on the other hand, we can also get visibility. So it's a win-win situation. So our idea is to have everything free software. Up to now, everything is free software. You can go, we have GitHub repositories and the like. You can go there and download everything. Okay, so thank you very much.